That's what I want. Okay. So I'm here to talk about Pharo Smalltalk as a universal development platform. So probably this catches some memories for many of you. The real point here is the IDE, the idea that we have this really rich development environment, and we'd like to be able to use it in all sorts of different platforms or in different ways. So why Pharo or other modern Smalltalks? First of all, we want to program in Smalltalk. It's obvious. Because it has the best-in-class IDE. I, in preparation for this talk, did a search for the best IDEs. And the ones I came up with, or that Google came up with, were not very impressive for the most part. Certainly from a Smalltalk perspective, it was like, really? That's the best you can do. Okay. Live object debugging, plus, of course, the previous talk, the idea that you can debug individual objects. I mean, nobody else has anything faintly resembling that. And all the other things at this conference. The glamorous toolkit, the idea that you have all this power that you have available, Rasal, Dr. Test, Seaside, Scientific Workbench, and so much more. So there's just so many things that we have in this community that nobody else has, including, of course, what Dave West had to say yesterday. So what Pharo? And I'll say Pharo, but I include others. But Pharo seems to be at the bleeding edge to some degree. So obviously desktop, and we saw earlier today about how you can build standalone applications and so on the desktop. So that's cool. It's interesting. Headless, we also heard earlier today about all the cool ideas on going forward on headless applications. Configurable images, be able to build an image that has just the pieces that we want. Those are kinds of things we want to be able to do. Command line scripting, it sounds like Pharo's making some good progress on that, but still, you've got an image to load. It's going to take a bit of time, so there's other ways you might want to do that. You want to build stuff for the web. PharoJS, I would argue, is the best way to do that. And maybe we want to use Pharo to generate standalone applications with Elysium. So how do we do this? Well, there's a whole bunch of tools that we have available here. So we can extend things by adding primitives or plugins using Slang or Elysium. I presume Elysium will get there. I'm not sure exactly where that status is, but FFIs. So we can use, Pharo uses FFIs very extensively internally, but we could use FFIs to get access to the whole world that's out there. So some of the things that I'll talk about a bit later where people want to use other ways of doing things really could probably be better addressed under using the FFI. You can also do things by communicating. So you can communicate with another VM, for example, the Python bridge. The idea that there are some tools that are available there that you want to be able to access using some kind of inter-process communication. So that's another way of doing things. All of this, of course, means that we can run our application within Pharo. Transpilation is the next possibility, and transpilation basically means to convert from one source language to another source language. So there's many people that are interested in this. PharoJS does this, Transpiles to JavaScript, Elysium to C, PharoJVM to the Java VM, Woden to shaders and so on for GPUs. And the last approach is embedded VM, which I had to add to the slide a couple minutes ago, based on the idea that in the not too distant future, you might be able to actually build a VM and include your Smalltalk code in some other application, which is pretty cool. So I'm going to talk mostly about transpilation. Why would we want to transpile? Well, because we have this friendly environment, development environment language, and we want to use it in some context that only supports ugly ones. So basically the deployment target, whatever it is, has some kind of limitations. So it's a GPU and it doesn't support a Smalltalk interpreter, or it's a browser and only supports JavaScript, or it's a cloud provider that only supports choose a platform, or because of footprint issues. We don't want to ship a even 30 megabyte image onto an embedded device, for example. So there's various reasons why we might want to transpile to some other language. How do we do this? Well, basically, a transpiler, many of you may know this, but I'll go through it anyway. Basically, we'll walk the compiler AST. So Pharo has a very accessible AST, very stable AST for the last couple versions, and Marcus asserts that it probably will stay that way for a while yet, so that's good. And typically, the first step is to translate this to a target AST. And why do you do that rather than working directly from the Smalltalk AST? Well, because there might be things in the target language that aren't directly representable in, or directly represented in the Smalltalk AST. An example is in PharoJS, there are for loops in JavaScript. And so we want to convert other things into for loops. So translate the AST. Then, depending upon what your target is, you may have to do some type checking or type inference. So, and this generally type inference means figuring out what the type of something is based on how it's used. And languages like Haskell and the functional programming community use this extensively. Rust is another language that uses type inference very productively. And there's been some work on soft typing and type inference in Smalltalk. The role typer is the classic one everybody trots out. But the role typer was trying to get approximate types that were going to help you understand your code, not to get specific types. And if you're generating code for a target that is a typed target, you need absolutely final types. You need to know the actual type of something down to it's an int or it's a float, not it's a number. And so you may have to do some kind of type inference. And in general, to do this on the entire image, this is a very challenging thing to do. It takes a significant amount of time, and there's lots of places like, what type does yourself return? Well, it depends. So doing accurate type inference on the whole image is kind of challenging. However, if what you're doing is connecting up with an API from some outside world, then you have a lot of type information already available to you. And so that type inference sort of gets seeded in a way that can make the type inference work quite well. Then you do optionally some optimization on that target AST. So in fact, in PharoJS, this is an example where that for loop AST actually gets put in the optimization phase. And then finally, you walk the target AST, generating the target code, whether it's a source code like JavaScript, or whether it's a class file like in PharoJVM. So just as an example, talk briefly about PharoJVM. Again, we want to program in Smalltalk, but sometimes you need to deploy in some kind of your organization's using WebSphere or something like that. You need to deploy there, and you don't really have a choice. It's been mandated by the company. And so you want to be able to generate code that will work there. Another reason why is that you want to access some framework. So Yarn as framework, does all sorts of cool stuff, but it's written in Java, and you want to access that. Minecraft is another. It's a very popular game, and I was trying to teach some kids to program last year, and so I started the work on Pharo JVM based on that. There might be performance advantages. the JVM has, huge amounts of commercial work behind it, and so it's a pretty high quality JIT. And so converting your code to JVM and running it on one of those commercial systems might be worthwhile. In the future, part of the rationale for PharoJVM was once we have the types, we could combine it with some of PharoJS, and we could generate either WebAssembly or our native code. And another reason is you might be able to generate Android apps directly from your Smalltalk code, because Android uses the JVM. Or actually, no, not the JVM, a JVM. Just as a tiny example of how this might look, Minecraft, how many people know about Minecraft? Okay. The rest of you don't have young kids, I guess. So Minecraft is a really popular game with kids. And it's this very engaging world that you can build. And this programming book that I was going to teach from last year had a lot of cool little plugins that you could write for Minecraft. In particular, there was lava vision. So basically, wherever the character looks, whatever's in their view turns into lava and starts destroying the world. So it's kind of fun. So this is an image of what it looks like. And here's the Java code to do it. It's not horrible, but it's pretty annoying. And so I looked at this and I said, I don't want to be having to deal with kids having to understand what all this magic incantations are. So this is what it would look like in Smalltalk, which isn't that much shorter. It's not that much different, but fewer concepts that I have to introduce. I don't have to talk about what void is and what public is and all that kind of nonsense. So one of the challenges of compilation, of transpilation in general, is block closures. So block closures have a few different challenges associated with them. The first of these challenges is that block closures can live past the lifetime of the method in which they're called, in which case they have to be allocated on the heap and various challenges like that. But they also have to be able to access shared variables. So here we have to access X from within the method and also from within the block that we create. So that's issue number one, and that has to be done correctly, and it's easy not to get it quite right. The other is the non-local return that you see in the third last line there on line 9. And non-local return is a Smalltalk thing. Nobody else, and no other language that I'm aware of, other than continuation-based languages where you can pass in a continuation that you can go arbitrary places. No other language that I'm aware of supports anything like this. So it's, again, a significant challenge on transpilation. If you want to support full Smalltalk semantics, if you're willing to handle only limited cases, life is easier. So then I'm going to talk about a few different possible transpilations and just some of the challenges associated with them. So PharoJS, both JavaScript and Smalltalk have dynamic or manifest types, so that makes life relatively easy. However, JavaScript is prototype-based and Smalltalk is class-based. And so if you're going to generate JavaScript, you have to be a little bit clever about how you simulate classes. In particular, the Smalltalk class hierarchy is, or the complete data structure of the class hierarchy is a general graph. It's not a tree. And in JavaScript, that's a little bit difficult to construct, but it's possible. Non-local return is a challenge. So in JavaScript has nothing resembling a non-local return. However, it does have exceptions. And if you use exceptions in a very tricky way, you can get non-local returns that work perfectly with Smalltalk semantics. Next is almost everything is an object in JavaScript, except for undefined and null. which aren't. So that means every time you send a message, you have to check to make sure that the thing is not undefined or null. Otherwise, you'll get a runtime error. And exceptions are not restartable, so that doesn't help. The numeric stack is deficient. Everything is a double precision floating point number in JavaScript, and strings are immutable. So you're not going to get perfect semantics, but for lots of applications, you can get good enough. Another challenge is that infix arithmetic, saying 3 plus or x plus y, is significantly faster than a method call where you do that. And so this means that in PharoJS, we do optimizations to try and convert message sends into infix arithmetic where possible. PharoJVM challenges. Smalltalk is dynamic. JVM is intrinsically statically typed. And modern Java, if you read books, it makes it look like it's kind of supports dynamic types. It doesn't really. The VM is still static. There are dynamic type things, but everything actually has a static type, and you have to recognize the static type. So when you put things into a parameterized a vector or something like that, and then you take them out knowing that they're capital I integers or something. In fact, the Java VM code that's generated from that specifically says, after we pull it out, is it an instance of integer? So it actually has to check that at runtime. And of course, that may be optimized away, but so we have to generate completely statically typed code. You could create everything as an object or a subclass of object like Scala and Jython and some others do. But for example, if you wanted to allocate all your integers as capital I integers, that means that you have to heap allocate them, and you have to extract the values when you want to do anything with them. So this is going to have huge performance. There's also no methods for add and so on. So even though it's an object, it doesn't act like an object like we would think of a numeric object. There are 8 primitive types, and to actually get any reasonable performance out of the JVM, you have to leverage these types. You have to use real Booleans, not capital B Boolean. Other challenges, there's no non-local return. If you're interested in the details of how to do this, I had an IWST talk last year where I talked about how to solve, I think, all of these, except for the deficient numeric stack and immutable string. So you're not going to get a perfect translation, but you might get something good enough. When I sent out an email asking for people interested in Transpilers, I got a response from somebody who was interested in Python, and after some thought on this, my question is, why bother? Not that it's a crazy thing to do, but the reason why people would actually want to do this is that Python has a huge access to a lot of libraries, and as well as a lot of code that's been written in Python. And the reason to do this would be you'd get immediate access to this. In the long term, the languages aren't different enough that it's probably worth writing a transpiler. It would be better to use FFI and provide access directly to those packages. But that's more of a long-term thing. And also the other rationale for this, or counter rationale, would be that the Python bridge looks like it provides you access to that in a pretty reasonable way. Challenges, again, no non-local return, block closure. I'm not completely sure whether it works. And they're missing fractions, but probably that doesn't matter for most cases. Challenges for compiling to GPU or transpiling to GPU or NoSQL or SQL. Types, again, these are typed systems. But these are probably useful if you're interested in only limited semantics. So in fact, compiling to the GPU, as Ronnie talked about yesterday, is a pretty reasonable approach. In fact, it's a nice approach. The main reason to do this is that you can develop your code in a common environment. You may even be able to test it and so on before you generate the transpilation. So it's a cool idea. And the last one I have is challenges for generating C or WASM or native code. Again, we have the type problem, dynamic versus static typing. Garbage collection, you've got to provide some kind of garbage collection, although WebAssembly does have garbage collection coming real soon now. And so you could leverage off that. Non-local return, again, you have to find a way to do this. In C, this is set jump, long jump. But I'm not sure whether there is a WebAssembly equivalent. But you could fake it. You could create everything as objects, but again, these are statically typed environments, so for reasonable performance, you need to avoid this. And block closure is going to be a challenge, and you either have to include the Pharo numeric stack as part of what you're transpiling, finding a way to do that, or you'd have to code your own. Conclusions. Well, so if what you want to do is you want to program in Smalltalk and access the world, there are lots of options. Leveraging the FFI is probably the best approach in many, many cases. But you can also use transpilation as another approach. It's significantly more work, but sometimes it's the only thing that really will work for you. And transpilation is probably not going to give you perfect Smalltalk semantics. Getting it absolutely equivalent is going to be very hard. But often you don't need you don't need fractions, or maybe you can survive with the JavaScript floats for integers and so on. So transpilation's popular. There's lots of people that are interested in doing it, and it would be nice to create a common infrastructure. So I've done some thinking about that, and I'd love people to contact me if they have any ideas about what that would look like. So, any questions?
It's not a question. I just wanted to let you know that Ruby has non-local returns.
Sorry?
Ruby has non-local returns.
Okay.
That just wanted to let you know that.
Yeah, not surprising. Ruby is Smalltalk with different syntax, so yeah.
So in your previous slide, you were talking about the common infrastructure for transpilation.
Yeah.
The thing is that when you explain transpilation, you said, okay, we have the source AST, which is the same for all the different targets.
Yeah.
And then you have a target AST that is different for each target. So can you expand a bit more? What are your ideas on that?
So PharoJS is sort of the most complete transpiler that I'm aware of. I mean, other people have done transpilers, but for fairly targeted purposes. In PharoJS, we want to take essentially, you've got a class and you want to transpile it and everything else it depends on. So it has a fairly robust, is probably overstating it, but a relatively mature-ish idea of how to actually find all those classes. So the top few levels of how PharoJS does this are, I think, a good model for, at least as a first run, for how to do this. And then you'd have a subclass of the transpiler that generated your own AST and so on. That's kind of, and also for typed transpilation, I think we could have a plugin that was kind of a uniform, at least structure for how to do that.
Okay, so the idea is to share all the source part and get more.
Yeah, so finding out all the classes that you need, going through all the methods in the class, going through the class side and the instance side, and so on and so forth.
Okay.
So I think that there's a fair amount of commonality there beyond now that you've got a method, you need to walk the AST. Yeah, from there on, there's differences, but up to that point, it's pretty common, I think.
Okay, thanks.
Anything else? Thank you.